Gentlemen, welcome back to the Edit Suite. Today is the highlights of Cinelerra version 7. The most essential feature is a more optimized playback pathway. This should greatly improve 4K playback at 30 frames per second if you have an ancient confuser, and greatly reduce the CPU usage if you have a modern confuser. It doesn't affect smaller frame sizes at higher frame rates because those are more limited by latency. Now let's load everybody's favorite footage, the SpaceX landing. Gonna select it in the load dialog. Select concatenate tracks and execute. To get the most optimized playback, you have to use plain old X11 as the playback driver. The scaling equation doesn't matter. You also have to go to the resources, right-click, and select Match All to conform the project. Frame rate, frame size, cropping, zooming, muting, and fade all have to match the source. There can't be any effects. The color space doesn't matter. So now when we play it back, it's using the most optimized path possible. So let's play it back while watching the frame rate. Resizing the playback window still uses the optimized pathway. Because I can't afford a 4K monitor, the video is always being resized, and there's no way of knowing if this confuser can hit the full frame rate at full resolution, but the chances are pretty good. Now let's profile it at double speed by selecting the double speed playback. It still almost does the full 60 frames per second in this scaled window with no problem. Now let's try double speed with X11-XV as the playback driver. So I'm going to select it here, select X11-XV and hit apply, and then play double speed. Here we can see this method is actually slower. If we select OpenGL as the playback driver, play it back, it's actually the slowest. It's not clear why X11XV and OpenGL are slower, but it seems the CPUs have gotten a lot faster at YUV to RGB conversion than the graphics cards. There is also a lot more memory copying when using OpenGL. Doing more calculations between moving each pixel instead of doing them between moving each frame is how you get higher frame rates. Similar to playback optimization, screen capturing was also optimized and got the ability to record the mouse. This feature is absolutely worthless unless you're making tutorials on how to use Cinelerra. But maybe you want to record copyrighted video. We must first go into Preferences and configure it to record the screen. So we select Recording. Now the ideal video format for recording is QuickTime. And we want to use H.264 with fixed quantization 25 and below. This process is optimized enough that temporal compression is no problem, and it works better than motion JPEG. Since this screen capture is going to happen inside another screen capture, we have to use a smaller frame size and a lower frame rate than what it can actually do. But even an obsolete 7-year-old confuser can still do 1920 by 1080 at 24 frames per second if you're not already recording anything. So let's open the project format. The aspect ratio is taken from the project settings. So we want this to be 4:3. Now when we go to File, Record, the recording interface begins monitoring the screen. Make sure the file that you're recording to isn't the same file that you're already recording the tutorial and screen capturing to. And make sure the checkbox for monitoring video is checked. Now in the recording monitor, there are options for recording the mouse and magnifying the mouse, in addition to the previous options for monitoring the color space. So here, when I move the mouse around, you can see that it's capturing it inside the recording monitor. You can select big cursor or small cursor to either double the size of the cursor or record the native size of the cursor. Or you can disable cursor recording entirely. And you can enable or disable monitoring the color space. To reposition the recorded region, click inside the monitor and drag it to move the window that's recorded. There's now a black border on the actual screen to show what content is being recorded. Right-click inside the monitor and select Reset Translation to reset the recorded position. The next big feature is factory presets. Because many parameters in Cinelerra tend to be at a low level, the effects can require a lot of tweaking to get good results, or they can be completely useless if you don't know the meaning of low-pass filter, which a lot more of the current generation doesn't than 20 years ago. So let's go to File, Load, and load everybody's favorite video, the first successful rocket landing. Select Replace Current Project and concatenate tracks, then hit OK. Now we fit the timeline. Right-click on the asset, select Match All to conform the project. Now as I play, from the right position,
ourselves down as we get closer and closer to the landing pad.
Yes. Now this stuff is super hard. Not only do we have a series of maneuvers that we need to achieve in order to get that rocket back down to the ground, but it's actually a super complicated thing. Like, you did some cool analogies, some cool math.
it's pretty quiet. What for no one knew what was going to happen, and they were all whispering. Now let's apply an effect everybody should be using on their videos, but nobody does. The compressor. So we go to Audio, Attach Effect, select the Attach Standalone and Share, and Compressor. And that attaches it to all the audio tracks.
Ourselves down as we get closer
Now
and
by
closer to the
default,
landing pad.
the compressor does
Now, this
absolutely
stuff
nothing.
is super, super hard. Not only do we have
And you're presented with a lot of parameters here. But instead of having to tweak it, we can now go to the timeline, right click on it, go to presets, and see a list of presets with asterisks. These are the most common factory settings which have been used for the last 20 years. Select loud and hit apply. This sets the compressor to the most useful settings for making all peaks as loud as possible.
Ourselves down as we get closer and closer to the landing pad.
Yes. Now, this stuff is super, super hard. Not only do we have a series of maneuvers that we need to achieve.
Now if we select soft, hit apply, it's going to let more of the peaks fall below the maximum.
Ourselves down as we get closer and closer to the landing pad.
Yes. Now, this stuff is super, super hard. Not only do we have a series of maneuvers that we need to achieve in order.
Now inside the presets window, you can't save or delete the factory presets. To make changes, you have to delete the asterisk and then click Save to create a new user preset. Now if you absolutely can't stand some of the presets and have to change them, there is a file in your Cinelerra executable directory called Cinelerra_factory. If we load it in a text editor, it has all the presets for every effect in one file. But if you change it, you'll have to merge it with any future releases from the factory. That's why there's also a file of user presets inside your .bcast/Cinelerra presets. Now there's just one other thing. Spherical video was big in 2016 and was handy for recording this year's total solar eclipse, so some minimal support for converting dual lens footage into equirectangular footage made its way into Cinelerra. It only works with dual lens systems like the Gear 360. It doesn't import any metadata like orientation. So let's load a spherical photo captured from the Gear 360. Let's go to our resources window. Select Match All to conform the project. Now notice we have a very large frame size. If we go to Settings Format, you can see we have a very large frame size, which is going to be very slow to chooch on this obsolete confuser. This is a perfect job for a proxy. So go to Settings, Proxy Settings, and select 1/4 to get a reasonable size by 10-year-old standards. It quickly renders a scaled image, since we're only using a still photo. If this was a video, it would take a lot longer. What you want to do now is transform this dual fisheye image into an equirectangular projection so it can be viewed in a standard spherical viewer. Right-click on the track, Select Attach Effect, and then select the Sphere Cam effect. Click on the magnifying glass to open the GUI. There are quite a few sphere cam parameters. Unlike the other sphere mappers, there's no automatic configuration based on control points. What for that method still requires tweaking. Not many people are still making spherical videos. And once a camera is configured, it theoretically shouldn't require a lot of tweaking again. Now the sphere cam probably won't work if the camera has autofocus, since that changes the field of view and requires reading metadata. This was only tested with a fixed focus camera. The easiest way to configure this is to go to your factory presets, right-click on it, and select Presets. This particular camera has different settings for photos and videos. If it says 7K, it's for a photo. If it says 4K, it's for a video. If it says sideways, the camera was mounted sideways. If it doesn't, the camera was mounted vertically. So for this photo, we want a sideways 7K. So select that, hit apply, and that gets you most of the way there. Now it's time to fine-tune the parameters. This effect was written for a 2-lens camera. So all the parameters on the left are for the left lens. All the parameters on the right are for the right lens. To start with, disable all processing by going to the mode and selecting Do Nothing. Then, select the option to draw the guides on the screen. This allows us to configure the first few rows of parameters by showing where the input is taken from. Click on these two toggles to enable or disable each eye. First, we have to configure the field of view. The first row is the field of view. This isn't drawn on the guide, but is used to compute the output. The next row is the radius, which is only drawn on the guide, but doesn't affect the output. This aids in finding the X and Y center of each eye. So you want to tweak the radius so it lines up with some detail on the screen that you can use to center the input. Now the next two rows are the input X and the input Y. These can only be configured with the guides on and with no processing. You need to tweak these and the radii so the circles line up with the edges of the eyes. So the left eye is pretty good. The right eye is a bit off. So we just want to use the mouse wheel and move it just a little bit. Now with the eye inputs done, we can focus on the output. The guide shows us where the output is going to go by drawing these vertical bars. If I adjust the output X of the right eye, you can see its bars move. Now adjusting the output X of the left eye is a little trickier. It's only going to move one bar at a time. What the program is doing is it's expanding the left or the right border so the two eyes overlap. This effect only knows how to draw the eyes side by side, not on top of each other. The output is always full height and half the width of the frame. The next parameter we're going to talk about is the feathering. You can adjust the feather to change the amount of overlap between the two eyes. The normal range is 1 to 2 for the final product and 4 for the alignment process. So we want to set it to 4 when we're aligning these two eyes. And to rotate the output, we adjust the rotate parameter, which isn't drawn on the guides. So let's recover the original preset. Gear 360 sideways in 7K. And let's turn on alignment mode by changing the mode to align only. And let's expand the feathering to help with the alignment by enabling the guides and then expanding this to 4. What the align only mode is doing is it's drawing an integer precision conversion with no gradient in the overlapping regions. When aligning the two eyes, the only parameters you should change are the field of view, the output X and Y, and the rotate. Changing the input to align the overlap won't work. So you want to start by tweaking just the field of view and the output X. And you want to alternate between these two to get the horizons to line up horizontally. And I'm just going to use the mouse wheel and make really fine adjustments. So now that the horizons are reasonably close horizontally, we want to tweak the output Y and the rotation to get the horizons to line up vertically. So once these are pretty well aligned, let's go to Settings, Proxy, and disable the proxy. Some more tweaking will be required at this resolution. And once you get it as good as you can go, change the mode to equirectangular and then reduce the feathering to about 1. Now let's render this to a file. So let's put in the file name. Select JPEG since it's a still photo. Now to generate output which websites will show in a spherical viewer, you have to output either a QuickTime or a JPEG still photo. In the compression parameters, for QuickTime it has to be H.264, and for JPEG you have to select tag for spherical playback. Check this off to generate the headers that websites need to see. If you forget to check this box, there's a utility in your Cinelerra directory. If you made a QuickTime movie, this utility takes a -360 argument to add a spherical header to the video. For still photos, you have to use a Perl program called EXIF tool. So if I go into the image EXIF tool directory, which is what it was called, there's the EXIF tool, and what you have to do to add the header is give it some magic parameters. That's it for the major new features. Go ahead and smash the subscribe button to see more examples of content produced on Cinelerra. And a big thank you to Cinelerra.org for supporting some of the development.